today we will start with the comparative study analysis. Last day we completed more or less the techniques, the application of the technique. How in context of more than one variables we are applying the optimizing technique and finding out the value of the function, and then how we are checking the second order condition and coming to the conclusion whether the derived value is a maximum, minimum, etc. So I think you are a bit familiar with the technique now. And in the next step, we are going for some comparative static analysis. Now, in context of comparative static analysis, we will consider different types of parametric shift. How this analysis is a bit different from the rest of the things we discussed so far. So far, we tried to find out the optimum value in terms of the parameters of the model. That was the end point. And then we checked using the second order condition whether the derived value is a maximum or a minimum, etc. So the problem stopped there. Now, in context of comparative static analysis, we will consider the parametric shift, and for that parametric shift, how our value function is changing, that we will like to find out. For example, if profit is a function of ultimately say W and R, in that case, we will like to find out if wage rate changes or rental rate changes, how the maximum profit function will change. So first we are deriving the equilibrium, which is the profit maximizing equilibrium, or say, some function where you are minimizing something. So you are finding the equilibrium value, which is an optimized value. Then how that equilibrium will change if we consider a change in the component of equilibrium. Okay, because when we are deriving the equilibrium value, that equilibrium is a function of several parameters. So now I'll change one of the parameters at a time, and with respect to change in that parameter, how the optimum function or the equilibrium value or value function is changing, that we will like to learn. So we are calling this comparative static result. Actually, we will consider a change in parameter and what will be its impact on equilibrium, that we will like to measure. So now we will consider several comparative static results for the profit function. This will be based on an analysis of how the profit function reacts with respect to changes in parameters of the model. More specifically, we will consider the optimum profit function, a value function, the derived value, the maximum profit, which is a function of input prices and output price, WR. It can be function of WR. It can be presented as a function of P, So later, when we will go for constant optimization, many a times we will consider output maximization subject to cost, and many a times we will go for cost minimization subject to output. So in one kind of problem, labor and capital will appear as the parameter. In other kind of problem, W and R will appear as the parameters. Okay. So in different circumstances, different parameters may appear. So the value function is a function of several parameters. In our case, the optimum profit function we derived was function of WR, P, etc. Okay. So now we will consider changes in this WR and P, and we'll like to find out how pi star value is changing or how the equilibrium is changing. The derivation of pi star with respect to input prices will generate the input demand functions, whereas the derivative of pi star with respect to output price will generate the firm's supply curve. So at this moment, I'll be not able to explain how these things are happening. When we will reach at a particular slide and when we will go for the derivation, we will find this thing. However, from the third point, it is evident that, starting from input, etc., we can reach at optimum function pi star say. Again, we can start our journey from the optimum function. Then we can also derive the input demand function from supply curve, etc. Okay. So our starting point may be Q as a function of L and K. And with the help of that, considering total revenue, total cost, we can define the profit function, we can maximize it. Okay, so this is one way of the journey. The second variety is we are starting from the optimum values, and using the optimum values, we may derive the input demand functions, we may derive the firm's supply curve, etc. Okay. So this section not only help us to understand several comparative statics, that is, when there is a change in the parameter, how the equilibrium is changing or how the optimum value function is changing, but also there will be some application of this comparative statics too. We can derive the input demand curves, we can derive the firm's supply curve, etc., starting from the optimum function or starting from the value function. Okay, so this is the second importance of this section. In derivation of firm's supply curve, if we consider all factors of production are variable, we get the long run supply function. Alternatively, if some of the factors are fixed while one or few factors are variable, we will get the short run supply function. This fourth point is actually echoing something, related to the last term in the last point, firm's supply curve. Now, when we are talking about firm's supply curve, or we are talking about derivation of the firm's supply curve, there can be two types of firm supply curve, the short run supply curve and the long run supply curve. If we keep some of the factors constant, we will get the short run supply curve. Whereas if we consider all the factors of production are variable, in that case, we will get the long run supply curve. So as per I can remember, in your first semester, in the micro classes, SM ma'am taught you about these things, the short run, long run, the production function, keeping some of the factors constant, production function, when all the factors of production are variable, then derivation of the industry supply curve, etc. When, there is a short run, and derivation of the supply curve when there is long run. Am I right? You have some idea about the short run, long run, fixing some of the factors in the short run. You have some idea?
Yes, ma'am.
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
Okay. So the points we need to keep in our mind. Number one, we are going for the comparative static analysis, which means we will consider the parametric shift. From where these parameters are appearing in our optimum function, they are there. These parameters are there in our optimum function. So one by one, we will pick and choose these parameters and consider a change in it. That is, wage rate is changing, rental rate is changing, or interest rate is changing, or price of the commodity is changing. Okay, because of these changes, how your equilibrium will react. So this you need to learn, number one. Number two, starting from the value function, how we can derive the several basic functions like input demand functions and output supply curve, because here we are talking about profit function. So from the profit function, we can derive these things. If the function is a utility function, in that case, starting from the optimum value function, we will be able to derive the demand for commodities. Okay, so it will depend on the original functional form you are considering. Here, profit is the original functional form. So we will be able to derive the input demand functions and firm's supply curve. And finally, you need to remember here, as we move, many points come inside, when we will go for this kind of derivations, the notion of short run, long run, all these things will also appear. So with this introduction, let's now move to the basic problem. So I'm considering a profit maximizing function. By this time, you are quite familiar with this profit function, which is equal to total revenue minus total cost. Now, to keep the analysis simple, again, we are considering two factors of production. Okay. So under most of the circumstances, you will find that when we are considering more than one variables, mostly we are considering two. Actually, if I want to parallelly do the graphical exercise only with two variables or two factors, we will be able to do the graphical part. So, and the mathematics is also simple with the two variables. So it will solve our purpose, and at the same time, the things are simple. So for that matter, again, we are considering two inputs of production, say x1 and x2. So the cost function is W1x1 plus W2x2 if W1 and W2 are the prices of the inputs. Okay. So in this problem, x1 and x2 are two inputs, and W1 and W2 are unit prices for these two inputs. P is the price of the commodity. P is the price of the commodity, and output function is a function of x1, x2. Okay. So in the profit function, this is P, the price of the commodity. This is basically Q, the quantity. So this part is the revenue, P into Q, minus W1x1 minus W2x2. So is this equation fine to all of you? The profit function, TR minus TC?
Ma'am, here we are not considering the inverse demand function, right?
Inverse demand function for what?
In the sense, like, I mean, usually for the profit function, we take quantity as a function of price, right? Sorry, the other way. Price is a function of quantity. So here we are just taking Q and then multiplying it with P.
For the revenue function, we do that. This P is a function of Q, no problem. Or we can consider P as given if it is a competitive context.
Yes, ma'am, yes.
Is only for monopoly.
Yeah, P is a, if it is competitive, we will consider P to be constant. If it is not a competitive context, in that case, P is not a given component, rather it will be also a function of Q. So all these things are there. So bringing entire thing in terms of input, that's all. However, the basic logic of inverse demand function, etc., that will be retained. Now, if you look at this P, and if I consider the price is a function of output, instead of considering a constant price, if I consider price as a function of output, we will consider the inverse demand. No problem. Okay. Okay, Kritika.
Yes, ma'am, yes, ma'am. I got confused with the notations, but I understood.
Yeah, there is no contradiction between the things we did earlier.
Yes, ma'am.
Okay. Okay, so pi is equal to what I have written, P into Q minus the cost. Explicitly here we are bringing L and K, say. Okay, instead of writing L and K, I have used the notation X1 and X2. Okay, so explicitly we are bringing those things, and P is the price of the commodity. Okay. Now the first order condition of profit maximization, we will consider the derivative of pi with respect to the first input, x1 say, So pi 1 is equal to del pi by del x1. The entire exercise I am doing here in terms of the inputs. Okay. So taking the derivative with respect to x1, and we are getting, P, we are considering the competitive price given from outside. Okay. And, this F1 is coming from this expression del F by del X1 that I am presenting as F1 minus, if I took the derivative with respect to X1, it is minus W1. By first order condition, we can set this equal to 0. In the similar fashion, we are taking derivative of this profit function with respect to the second output, say K or X2. So pi 2 is equal to del pi by del x2 is equal to P F2. Actually, del F by del x2, that notation is F2 minus this W2 if I take the derivative with respect to x2. And setting these two equations to be equal to 0 by first order condition. Sufficient conditions for a maximum profit will be given by pi 1 1 less than 0, pi 2 2 less than 0, that is mod h1 that is less than 0. So we are considering the Hessian determinant. Hessian determinant should alter in sign starting with negative. So pi 1 1, pi 2 2, these will be negative, whereas pi 1 1, pi 2 2 minus pi 1 2 square, that is h2, mod h2, that will be greater than 0. Any question? Any question? Since pi ij is equal to P if ij, pi ij, look at this, pi 1 1, pi 2 2, pi 1 1, pi 2 2, pi 1 2, etc. Pi ij, okay, say pi 1 2 or pi 2 1, this kind of thing, is equal to P if ij. P if ij. Are you understanding? This will be equal to P if ij. If you take pi 1 1, what will be the expression? Anyone? Del square pi 1 by del x1 square. What will be the expression?
P into F11.
This one. Next. What will be the expression?
PF22. PF12.
What will be the expression?
PF12 equals to PF21.
Yes. So is it clear? If I consider the second order derivative, that is pi ij, will it be equal to P if ij? P if ij? Is it okay to all of you?
Yes, ma'am.
Yes, ma'am.
So from this, so we can write this thing. If I is equal to j, in that case also it holds. If I not equal to j, in that case also it holds. So pi ij is equal to P if ij. So the second order conditions which I first wrote in terms of pi 1 1, pi 2 2, etc. Can we write it in terms of f then? Because P is a constant. If P is a constant, can we write all pi notations in terms of F notation?
Yes, ma'am.
So actually the signs will be determined by, pi 1 less than 0, pi 2 less than 0, then pi 1 pi 2 minus pi 1 square greater than 0. Everything will be determined basically by Fij. P does not have any role because P is positive. So we can express all pi 1 etc. in terms of Fij. So second order conditions, we are rewriting in terms of Fij's. So F11 less than 0, F22 less than 0, from pi 11 less than 0 and pi 22 less than 0. And from the second expression, F11, F22 minus F12 square greater than 0. It was pi 11, pi 22 minus pi 12 square. It is becoming F11, F22 minus F12 square. Okay, so this part is clear, I hope, to all of you. So a profit maximizing firm will employ resources up to the point where the marginal contribution of factor to producing revenues, which is given by PFI, the value of marginal product of factor I, PFI, what we are doing, Fi is the marginal product of factor I, that we are multiplying with P. That means we are considering the value of the marginal product of factor I. Value of marginal product of factor I. So what I am telling, Fi is the marginal product. Factor. If I multiply this with P, this is becoming value of the entire thing. Okay. So what I am telling, a profit maximizing firm will employ resources up to the point where the marginal contribution of each factor to producing revenue, marginal contribution of each factor to producing revenues, which is equivalent to PFI and which is equivalent to the value of marginal product of factor I, is equal to the cost of acquiring additional units of that factor, say Wi. What was the first order condition? Pf1 is equal to W1. The second one is Pf2 is equal to W2. So the value of the resource is equal to the unit price of the resource. The value of the resource is equal to the unit price of the resource. So it is said that a profit maximizing firm will employ its resource in such a way so that the value it is getting out of that extra unit is equivalent to the cost or per unit cost the firm needs to bear to collect or to gather that input. So this line has been written here. The implication or the meaning of the first order condition of profit maximization. Please go through the sentence and check that whether it is clear to all of you. If there is any confusion, please ask me. So look at these two first order conditions and look at the statement. Is there any confusion with respect to any point in this statement? It's okay? So So the last two equations, that is PF1. Now, these two equations are giving the first order conditions. Here we are writing the first order conditions, more clearly. It was P(F1) minus W1. Now F1 again is a function of x1, x2. So, in the previous equation, x1 and x2 was implicit. However, here we are explicitly bringing those x1, x2. This first order derivative is a function of x1, x2. This first order derivative is also a function of x1, x2. So anyone has any query, any question regarding this presentation of the two first order conditions? Is it okay? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. These two implicit relations is essentially 5 unknowns. Okay, so if I look at these equations, there are 5 unknowns: x1, x2, their prices, and the commodity price. Under the right conditions, it is possible to solve for 2 of these values in terms of other 3. Generally, what will happen, we will consider x1 and x2 as variables and W1, W2, and P as parameters. So generally, when we consider this kind of profit function, we will try to derive the values of x1 and x2 in terms of W1, W2, and P. Okay. However, there may be context when we are deriving the values of W1 and W2. In that case, W1 will be function of x1, x2, P. W2 will be function of x1, x2, P. So in that case, the input prices are becoming the variables, and labor and capital, these are becoming the parameters of the model. So here we are considering L and K as the variables and their prices as well as the commodity price as constant. However, there may be a situation when W and R can be considered as the variable components. In that case, the labor and capital, these will be given to us. The volume of labor and capital we can use, that will be given to us. So L, K, and P, or x1, x2, and P will be the parameters of the model. Okay, Oyon is here.
Yes, ma'am.
Oyon, আগের দিন তুমি একটা query করছিলে না?
Yes, ma'am. I was talking about this equilibrium quantities only. Means they will be the function of the parameters.
Yes. So L and K may be the parameter depending on the context. W and R may be the parameters depending on the context. Okay. So 5 unknown components are there. Under the right conditions, please check the right has been kept within inverted comma, because as long as we are considering or discussing everything with respect to the unconstrained profit maximization, we are doing the things in some way. However, later we will go for constraint optimization, so sometimes we will minimize cost. In that case, we will consider output as given, and under other circumstances we will maximize output, and in that case we will consider cost as given component. Okay, so it will depend from what angle you are solving the problem. So under the right conditions. Okay, so I think your confusion is over, isn't it?
Yes, ma'am. It's clear.
Okay. Okay. Okay, so this is the thing, x1 and x2. Here we are considering x1 and x2, as I told you, variables, w1, w2, and p as parameters. Now, if I write the equations in this way, these are the factor demand curves or the optimum choice functions. Factor demand curves, x1 and x2 are nothing but the labor and the capital functions. So these are the input demand curves. These are all explicit functions, because these are functions of, parameters W1, W2, and P. So these are all explicit functions. It is not the implicit function. This is explicit functions. Now, what we can do, we solved for these x1 and x2. We solved for these x1 and x2. Actually, solving these two first order conditions, or these two first order conditions, the same thing. Solving these two first order conditions, we can derive the values of x1 and x2 in terms of W1, W2, and P. Okay. So we can find out x1 star and x2 star. So these are the explicit functions. Now, what we can do, we can then substitute these x1 star and x2 star, that is the equilibrium value, in the first order conditions, and rewrite the first order conditions, which is in this page, as, I'm instead of x1 and x2, we are bringing the particular value of x1 and x2. Particular value of x1 and x2, which we get solving the two equations. So Pf1, x1 star, which is a function of W1, W2, and P, x2 star, W1, W2, and P. So what step by step I'm doing? This was the first step, taking the first order conditions. In F1 and F2, x1 and x2 are there, implicit in F1 and F2. x1 and x2 are implicit in F1 and F2. In the next step, we are bringing the implicit values here. F1, which is a function of x1, x2, etc. Solving these two equations, getting x1 star and x2 star. Then again substituting those x1 star, x2 star in these equations and getting two particular equations at equilibrium. So these are not telling us the equations are at equilibrium, because from here we will derive the equilibrium value. Now when
Ma'am, but here only x1 star and x2 star satisfy this equation. So will we not write here only x1 star, x2 star?
Please listen to me. Please listen every step. First, I told you this is the expression we can write in this way. The first order condition simply, where x1 and x2 are implicit. Then we are bringing x1 and x2 in this equation. These two equations are functions of x1, x2, w1, w2, p. Then we are deciding with respect to which variables, x1, x2, w1, w2, p, everything, especially x1, x2, w1 and w2 can be treated as variables. In this particular model building exercise, from the very beginning, I am considering p as a constant because it is a competitive framework. Okay. So, x1, x2, w1, w2, any of these four, we can solve for any of these four. We can either solve for w1, w2, or we can solve for x1, x2. However, in this context, we are interested about the input demand. So, we will solve for x1, x2 in terms of w1, w2, and p. So, we will consider w1, w2, and p as parameters, and x1 and x2 will be treated as variables. Solving these two equations, therefore, we are deriving x1 star and x2 star. Once we solve these two values, x1 star and x2 star, which are functions of w1, w2, p, on which we agreed that we will find out the input demand. Therefore, we are considering x1 and x2 as variables and treating w1, w2 along with p as parameters. So once we get those x1 star, x2 star, we are putting the values here, and these are expressions at equilibrium. Because these x1 and x2 are not any x1 and x2. These are the typical x1 and x2 for which you solve the things. These are these typical values. So we are replacing the general x1, x2 by these profit maximizing values. Okay. So this is the difference between this equation. Here x1 and x2 can be any equation, any value, sorry. It can be equilibrium, it can be anything. Here, typically, we are solving the two equations and replacing x1, x2 by their equilibrium values. Is it now clear to all of you, one by one, how we are developing the steps?
Yes, ma'am.
These are the two equations at equilibrium. Now we can consider the parametric shift, etc. Okay. So in the next step, we will move towards the comparative statics. First, we are presenting the equations at equilibrium. Now, differentiating the above equation with respect to W1 and applying the chain rule, we can write, in the next step, as I mentioned, when we are getting the values at equilibrium, in the next step, what we will do, we can consider change in W1 or W2 or P, and can measure the comparative statics. If I change W1, what will happen to this equation? If I change W1, what will happen to this equation? Okay. Or W2, what will happen to these positions? How equilibrium will change if I consider a parametric shift? This kind of things we are going to consider. So I'll take derivative of this entire expression first with respect to W1. With respect to W1. Then we will consider the derivatives with respect to W2. Then we will consider the derivatives of these two expressions in terms of P. So one by one I'll do. First, I'm considering the derivative with respect to W1. So what is happening? The expression was P F1 and F1 was a function of W1. P into F1 and this F1 was a function of W1. F1 is a function of X1 and X1 is a function of W1. So the expression will be P del F1 by del X1 and into del X1 star by del W1 plus P del F1 by del X2 star by del W1 minus 1. We are taking derivative with respect to W1. So, P this X1 is the X1 star, the typical value. So, we are doing this plus what will be the second expression? If here also we have W1. Okay, here also we have W1. So P
df del f1 by del x2 into del x2 star by del w1.
Yes, very good. Del W1. Because both x1 star and x2 star are functions of W1. So we have to first take the derivative with respect to x1 star and then also with respect to x2 star minus
1.
this W1 is there, so minus 1 equal to 0 or equivalent to 0. Okay, so this expression is there. P P del F1 by del X1, del X1 star by del W1 plus P del F1 by del X2 star by del W1 minus 1 is equal to 0. So this expression is there. In the similar fashion, we can do the same thing for the other expression PF2. So it will be, tell me what will be the expression? P, sorry, del F2.
Ma'am, it will be P del F2 over del X1 times del X1 star over del W1, then
plus del
plus
F2
P.
by del X2.
Del W2. Del W2.
Ma'am, I thought we were differentiating. Oh,
Yeah. Now I am considering.
yes, 1.
So,
And then it will be plus P into del F2 over del X2 into del X2 star over del W1.
yes. And here there is W2. So the value is, okay, so this expression we will get. So let's check. We got exactly this one. P del F2 by del X1, del X1 star by del W1 plus P del F2 del X2 star by del W1 equal to 0. Okay. Now using the subscript notation, we can alternatively write the first equation as PF11 del F1 by del X1. So it is F11. P F11 del X1 star by del W1 plus P F12 del X2 star by del W1 is equal to 1, and P del F21 del F2 del X1. So F21 del X1 star by del W1 plus P F22 del X2 star by del W1 equal to 0. So please check whether these two equations are understandable or not. Any question for these part, these derivatives and then writing the expression like this. Is there any question? Okay, so now we will like to solve for these two equations, and we will like to find out the values of del X1 star by del W1 and then del X2 star by del W1. That is how the X1 star or X2 star values will change if there is a change in W1. How? X1 star, that is the equilibrium value, optimum value, or X2 star, that is the optimum value, that will change, that will shift, parametric shift of the input demand curves. Okay, so how these X1 star and X2 star lines or values will change if there is a change in W1 or W2. Now we are considering the change in W1 only. Okay. So multiplying the first equation by F22 and the second by F12. This is the question of simultaneously solving the two equations. So you know how to do these things. So once you understand up to this, in the next step, remember you have to find out the values of del X1 star by del W1 and del X2 star by del W1. That's all. So, and you know how we can solve the thing simultaneously. So check everything, and then you can use the Kremes rule. If you are okay with Kremes rule, you can do it anyway. You can simultaneously solve the equations, or you can apply Kremes rule. We need the final values del X1 star by del W1 and del X2 star by del W1. That is how X1 star will change for any change in W1, how the equilibrium X2 will change for any change in W1. So first tell me, are you understanding the derivatives or not? The process. Is the process okay to all of you?
Yes, ma'am.
In the parametric shift, how we are considering the comparative static, or how we are deriving the comparative static results? It's not difficult, you have to understand, x1 and x2 are functions of this, that's all. So once you write down the optimum first order conditions, from there actually we are deriving del x1 star by del w1 and del x2 star by del w1. Okay, and from the second order conditions, we ensured this expression is not equal to 0. From the second order requirement, we ensured these expressions are not equal to 0. In fact, this expression is positive. Okay, so this expression is positive and these two expressions are negative. So here P is positive, the denominator is positive, the numerator is negative. So what is the sign of del x1 star by del w1?
Negative.
Negative.
Negative. Okay. Now what is the meaning of this negative sign? What does it mean? Del x1 star by del w1 less than 0. So what does it mean? Is there inverse relation between x1 star and w1 or positive relation?
Inverse.
Inverse.
Inverse relation. Now what the inverse relation means, So tell me in sentence, what does this inverse relation means? What?
If W1 increases, exchange x1 it will reduce.
Yeah, that we know. That we know. Now in terms of the economics, language of economics,
Per
If
unit
the factor
cost
cost
of the
increases,
factor
then
in, yeah.
the production will be decreased.
okay. Okay, so demand for input X1 will fall if the price of this input increases. Can we say this thing? As price of input 1 increases, demand for input 1 will fall. Can we tell this thing?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
X1 is labor and W is the wage rate. As wage rate increases, the producers will employ less labor. That is, the demand for labor will fall. If wage rate increases, demand for labor will fall. This is indicating this thing. Okay, so for increase in own price of the factor demand falls. Alternatively, here what we are getting, what is the sign of this? Can we say something, or it is ambiguous?
Ambiguous.
Ambiguous. Okay, so it will all depend on F21. Okay, denominator is positive. If F21 is positive, this is negative. That is, as W1 increases, price of input 1 increases, demand for input 2, that is also falling. Demand for input 2 is falling. That indicates actually the two factors are complementary in nature. Isn't it? Are you understanding? Because this is the cross relation. Del x2 star by del w1. Okay, it is a cross relation. So if this is negative, what does it mean? If this is positive, what does it mean? If the sign is negative, inputs are complementary in production or substitutes?
Substitute.
Complementary.
If negative, what does it mean? If positive, what does it mean? Bolo, one by one bolo. Negative hole ki indicate kore?
Complementary.
Compliments.
Compliments.
Okay. So it will depend on sign of F21. Okay, so looking at the sign of F21, you will be able to come to conclusion whether del x2 star by del W1 is negative, del x2 star by del W1 is positive, and you will be able to explain whether the inputs are complementary to each other, whether the inputs are substitutes to each other. Okay, so it will be this will be the case. This will be your conclusion. However, the first one will be generally negative. The similar thing you can do in terms of W2. Okay, similar thing starting from the first step, you know. Here we took the derivatives in terms of W1. Now you can take the similar derivatives in terms of W2. Okay, so you know, P del F1 by del X1 into del X1 star by del W2 minus P del F1 by del X2 into del X2 star by del W2 equal to 0. And from the second equation, P del F2 by del X1 into del X1 star by del W2 plus P del F2 by del X2 into del X2 star by del W2 minus 1 equal to 0. So these two equations you will be able to find out. Okay. So we can find out these two equations and simultaneously solving these two equations, you know, simultaneously. Once you get the derivative, simultaneously solving these two equations, you can find out del x1 star by del W2 and del x2 star by del W2. Now, if you look at the sign of del x2 star by del W2, it is negative. Okay, so as input price increases, demand for input will fall. And for this matter, the sign is ambiguous. It will all depend on sign of F12. So if F12 is positive, this entire thing will be negative. If F12 is negative, this entire thing will positive. Okay. So it will all depend on the sign of F12. So hope you are understanding how we will find out these equations, and from there, how we will find out del x1 star by del W2 and del x2 star by del W2. If anyone have any confusion or if I need to repeat, please let me know. So is it fine to all of you?
Yes, ma'am.
So two comparative statics done in terms of W1, in terms of W2 done. Next, we will discuss this comparative statics in terms of P. In terms of P, the third parameter. We had W1, W2 and P. So in the next step, we will do the similar kind of exercise taking derivative with respect to P. Okay. Now in between, if you look at these sentences, already these things are covered. By the second order conditions, we guarantee the negative slope of the factor demand functions. However, we cannot unambiguously specify the signs of the cross effects. So now, differentiating the first order conditions with respect to P, we have to take derivatives with respect to P. So I am going back to the two first order conditions. Would you please take the derivative with respect to P? Please take the derivative with respect to P. Now look at this expression, you know, it is P in this format. Okay. However, P can be treated as constant. Both x1 and x2 are functions of P. P is a parameter and the expression is in this form, you have to take derivative with respect to P. Are you doing the things?
Yes, ma'am.
Okay. Please check whether you are getting this kind of expression from the first equation. P F11 del x1 star by del P plus P F12 del x2 star by del P. Now, originally there was P into, okay, so if you take the derivative with respect to P, it is U into V format. So there will be F1 only. So that F1 can be considered or can be taken in the right hand side. So please check whether this is okay to all of you, or I'll take the derivative. Actually, it will be first F1 plus P into del x1 by del P into del x1 star, del F by del F1 by del x1 into del x1 star by del P. Then P del F1 by del x2 into del x2 star by del P. So three expressions will be there, and we are bringing minus F1 in the right hand side. In the similar fashion, we are taking derivative of the second equation with respect to P and check whether we are getting this expression. Once you get these two values, the next task will be to simultaneously solve these two equations to get the values of del x1 star by del P and del x2 star by del P. So please do these things and tell me whether you are getting these values, any confusion, whether I need to do anything, please let me know. If you get this expression, the denominator is still positive. However, what will be the sign at this moment, we will be not able to tell you anything, because it will all depend on what is the sign of F1, 2, etc. F11, F22 we know in the numerator. However, we have no knowledge about signs of F1, F2, F1, 2, etc. So in specific context, it will get specific sign. And accordingly, we will get the values or get the sign of del x1 star by del P. That is, if output price increases, whether there will be a reduction in factor demand, or if output price increases, there will be an increase in factor demand. Okay, so we will be not able to claim anything regarding that. It will depend on the particular numerical context. So are you getting these values, everyone? Did you solve for these two equations?
Yes, ma'am.
Yes, ma'am.
As I am understanding,
Yes,
all
ma'am.
people are not doing
Yes, ma'am.
Yes, ma'am.
and getting these values.
Yes, ma'am. Yes, yes.
Yes, ma'am.
Yes.
Okay. So I hope no confusion is there, you know. And as I mentioned, the sign directly we will be not able to discuss because it can be positive, it can be negative, all will depend on what are the signs of F1 to the first order derivatives, etc. Generally, the first order derivatives will be positive, you know, because del L by del W, del L, del K by del R, these things will be generally positive. So everybody, I hope, understanding, you know, how to find out the values of, you know, change in the optimum value with respect to change in parameters. So once the optimum values are with us, sorry, x1 star, x2 star, putting the parameters there, one by one, we are taking derivative either with respect to W1, both the equations with respect to W1, or both the equations with respect to W2, or both the equations with respect to P. And we are generating pair of equations. Solving those pair of equations, we are deriving the values of del x1 star by del W1, del x2 star by del W1, then del x1 star by del W2, del x2 star by del W2, del x1 star by del P, del x2 star by del P. So all 6 values can be generated with the help of this kind of derivatives or this kind of comparative static analysis. So anyone, any doubt for the comparative static analysis? Prithviraj, is it okay?
Yes, ma'am.
Konkona, Anandarupa, are you getting?
Yes, ma'am.
Yes, ma'am.
Great. So next is the output supply function.
Ma'am,
So
can you
input,
show the previous? Can you show the?
this one.
Yes, ma'am.
Any question or you are writing something?
Ma'am, I was writing, like I have already written, so I was just checking to see. Thank you,
It's okay.
ma'am. I'm good. Yes, ma'am.
So next is the output supply function. Output supply function. Okay. It is also possible to ask how output varies when a parameter changes. Okay. Now, once you solve for x1 and x2, that is once you find out the optimum use of L and K, you will be able to find out Q star. What will be the optimum amount of output? Now, in several exercises, first you derived the values of, you know, the variables in the profit equations, you know. First you derive the value of Q and then you plugged this value in the profit function and got pi star. So in a similar fashion, if we have the output function like this, output is a function of 2 inputs, L and K say, or x1, x2. Once we get the value of x1 star and x2 star, we can plug these 2 values in the original production function and we will be able to find out the optimum level of output. So it is possible to ask how output will varies when parameter changes, you know. So this exercise we are going to do. So y star will be equal to function of x1 star and x2 star, where y star is the profit maximizing level of output. Y star is the profit maximizing level of output. Actually, you did one mathematical exercise where you derived the values of L star, K star, and putting this value, you got Q star, I think, you know. So that kind of mathematical exercise here we are talking about. So Y star is the profit maximizing level of output. The factor demand curves are functions of prices. Already we checked, we considered the thing in this way. So Xi is a function of a W1, W2P, and the Xi value at equilibrium is given by Xi star. Okay. Similarly, X2 star will be again given by a function of W1, W2P. So we can plug the x1 star value and x2 star value in the y star function. So y star is equivalent to f of x1 star, x2 star. Now since both x1 star and x2 star are functions of w1, w2 and p, y star is a function of w1, w2 and p. This is the required supply function of firm. Okay. Although the supply function is commonly drawn only against output price P, factor prices must also enter the function, since factor costs obviously affect the level of output a firm will choose to produce. Okay. So hence, before this, generally, we considered the supply function, firm supply function or industry supply function is a function of P. However, if we broaden our analysis, we can find that it can be function of W1 and W2 too, because when the firm is producing the output, cost it is bearing always it is bearing a cost. Okay, so the output can be considered the function of price along with the costs the firm is bearing. Okay, so though we are more familiar with the supply function, which is a function of P, here we are stating that the supply can be a function of or can be considered rationally as a function of W1, W2 and P. To derive the effect of changes in supply prices on the level of output, we consider del Y P, del Y star by del P. Okay, del Y star by del P. Now, if I consider del Y star by del P, Y is a function of X1 and X2, and X1 and X2, they are functions of P. So again, we will consider the chain rule, function of function. So del Y star by del P is equivalent to del F by del X1 into del X1 star by del P plus del F by del X2 into del X2 star by del P. Now, del F by del X1 can be expressed as F1, whereas del F by del X2 can be expressed as F2. So, del Y star by del P, finally substituting the values of del X1 star by del P and del X2 star by del P. Now, from where we got del X1 star by del P, etc. from this equation. Del X1 star by del P. We got these values from here. Del X2 star by del P. Okay, so substituting these two values here, we can finally find out the value of del Y star by del P is given by this format. So what will be the best thing? Write down this expression. Del Y star by del P is equal to F1 del X1 star by del P plus F2 del X2 star by del P. Then in place of del x1 star by del p and del x2 star by del p, put these values and check whether we are getting the expression which has written in the slide. So I'll request all of you to plug del x1 star by del p and del x2 star by del p values in these expression. Del y star by del p, f1 into here, substitute the value, here substitute the other value and check whether you are getting this result or not.
Yes, ma'am, it's same.
Same? Very good. Others?
Yes, ma'am, it's same.
Yes, ma'am. It's
Yes, ma'am, it's the same.
Yes, ma'am.
Okay.
Yes, ma'am.
So it is del y star by del p is equal to this expression. Okay. Now once you get this expression, denominator, you are understanding this is positive already from the Hessian determinant, the maximizing condition, etc. That is telling us this will be the expression. Now the numerator also, numerator will be, the numerator will be negative to ensure the profit function is a concave function. Are you familiar with this expression?
Ma'am, is it not quasi-concavity?
I am considering the strict inequality. Okay. Quasi means, in that case, you have to add one equal sign, less than equal to you have to consider. So I am telling that the denominator is positive by sufficient second order condition. Again, the sufficient condition for concavity ensures. So this is the usual concavity condition. Usual concavity condition. Okay. It is the usual concavity condition when there are two variables in the analysis. You did it in your first semester course. Convexity, concavity. So the usual condition of concavity ensures the f11 f2 square minus 2 f1 f1 plus f2 to f1 square, that will be less than 0. So this is the sufficient condition of concavity. So sufficient condition of concavity ensures this will be less than 0. Okay. So here we have the expression which is negative of this one, which is negative of this one. Okay. So the numerator is negative, whereas denominator negative of negative, this is negative, and if you take a minus sign common, you will get this expression. So the numerator is positive, the denominator is positive, which indicates del y star by del p is positive. Okay. So the supply function with respect to price, that will be positive. Commodity supplied with respect to price, that will be positive. If price of the commodity increases, the supply of the commodity will increase, or the supply curve will shift to the rightward direction. Since we are talking about the parametric shift, so if there is an increase in price, the supply curve will shift to the rightward direction. So here it is indicating that. It is not the movement along the supply curve, because it is not del y by del p. Rather, it is indicating the fact that if the price of the commodity increases, in that case, the entire supply curve will shift to the rightward direction. This says that the sufficient second order conditions for the profit maximization imply that the supply curve, the numerator or this expression is always negative. This is coming from the usual definition of concavity. Okay. However, the sufficient condition for profit maximization, that is F11 F22 minus F12 square, this will be positive. This is positive. So the sufficient second order conditions for profit maximization imply the supply curve as usually drawn must be upward sloping. It also provides an explanation as to why it cannot be the case that both del x1 star by del p and del x2 star by del p are negative. Now here we have two things, del x1 star by del p and del x2 star by del p. Given F1 and F2 are positive, because these are the marginal products, given F1 and F2 are positive, if you consider both of these del x1 star by del p or del xi star by del p negative, you cannot have a positive del y star by del p. Okay. So it cannot be, when price of the commodity is increasing, simultaneously demand for both the inputs may increase, or at least demand for one of the inputs will increase. It cannot happen that demand for both the inputs are falling. It cannot happen that all the input demand will fall when there is it cannot happen that both the input demand as price of the commodity increases, demand for both the input will fall, because that will not allow to have a positive sign with respect to del y star by del p. So to ensure del y star by del p will be always a positive number, when there is an increase in price, there can be increase in demand of both the inputs, or at least there should be an increase in demand for one of the inputs. It never happen, it cannot happen that both the input demands are falling when there is an increase in price. Because when there is an increase in price, there will be an increase in supply. Supply curve will shift to the rightward direction. Okay, supply curve is positively sloped and it may shift to the rightward direction.
Ma'am, why shift here, ma'am? I'm not understanding.
Here our focus is on comparative statics. In our comparative static analysis, we are more interested about the shifts. In your micro class 2, in the last semester, you found that when we talked about the taxation, etc. So when we consider any kind of parametric shift, not only we will talk about movement along the curve, but also, the shift of the curve, because other things remaining unchanged, W1, W2 remaining unchanged, if there is a change in P, in that case, there will be a shift of the supply curve. So in comparative static analysis, concentration is on shift, parametric shift. If there is a change in this parameter value, not only we are interested about the movement of the curve, under most of the circumstances, there will be shift of the curve.
Ma'am, but here with respect to price in supply curve, we are plotting Y star and P star. So there will be, how will there be a shift?
Arun, I didn't get your question. Please repeat.
Ma'am, in supply curve, we are plotting P star with respect to Y star. So why will there be a shift? Means all we are seeing is an increase in price or
P
decrease
star
in
I
price.
didn't get. P star I didn't get.
Ma'am, P, only P. P and Y star.
Oh, P and Y. P and Y. When we consider
Ma'am,
P
but
and Y.
ma'am, but we plot Y star means the profit maximizing output in supply curve.
Yeah, so this is a specific output. Now, if there is a change in price, in that case, there can be a shift of the supply curve too. It's not that there will be only a movement along the curve. There can be a shift of the supply curve too. Okay? Okay, now I have considered a specific level, say, profit maximizing level of output.
Ma'am, but all these Qs are all profit maximizing levels only.
Why? All the Qs will be profit maximizing, We are considering a specific equilibrium value. Our profit.
Ma'am, but with respect to 1P, we will get 1 Q star only.
Your questions are very, very confusing, This is a single profit function. We are talking about a single profit function when we are talking about a function, So with respect to a single, level of output, single equilibrium output, there will be a single specific output, where the profit will be maximized. Okay. So it is not that it is a combination of inputs. It's a combination of several prices. All the things are there. If there is a change in W1, W2 and P, the profit maximizing level will change. This curve may shift like this. So profit maximizing level will change and that will bring a change in Q. Okay. So when we are talking about a specific profit function with respect to a specific output level, there will be a profit maximization. And that specific output level will consider a combination of two specific levels of inputs. Okay, so these are all equilibrium values. Now, if there is a change in P, this profit function itself may shift. Okay, so all these things are happening. Output is shifting. Input demands are shifting. So things are shifting like this. This is the idea of parametric shift. Okay, so this is not that along this curve, this is a combination of Q star. No, it's not that. Okay, with respect to this particular supply function and the given profit function, there will be a specific level of output at which the profit will be maximized. Okay. This is not the locus of all profit maximizing level of output. Got it?
Ma'am, but in the beginning, we started with that definition only of supply curve, means Y star of with respect to P star.
This Y star corresponds to the profit maximization.
Yes, ma'am. So
that is the source. We are coming from this, So this is our starting point. Okay, so we are talking about a particular level of F. Okay, so now we are working on this F. Okay. So otherwise, the idea of profit from where when we are talking about this, from where the idea of profit will come. So our starting point is a profit equation. Okay. It is continuation of the thing. Now you are getting the point.
Yes, ma'am.
It is also possible to derive some reciprocity relationships. What is reciprocity relationship? Del y star by del wi. Del y star by del w1, del y star by del w2, this kind of thing. Del xi star by del p. That is del x1 star by del p, del x2 star by del p. Consider this kind of cross things. Hence, so far, we talked about del xi star by del wi and del y star by del p. However, we can think about relationship between change in output with respect to change in input prices, or change in input demand with respect to output price. Okay, so in this way also we may relate the things. Okay, in particular, our interest is in showing this particular relation. Del y star by del w1 is equal to minus del x1 star by del p, and del y star by del w2 is equal to minus del x2 star by del p. Okay, so these are called the reciprocity relationship. So this will be your homework. Find out these relationship. So please write down. Your homework is to find out del y star by del w1 is equal to minus del x1 star by del p, and del y star by del w2 is equal to minus del x2 star by del p. I hope you will be able to do it, because you got y is a function of w1, w2. So all the cross derivatives you need to consider, and from these expressions you will be able to find out, taking derivatives with respect to p, you will be able to find out del x1 star by del p, del x1 star by del x2 star by del p. So I hope you will be able to do. So please complete this thing. So today I'll stop here. Next day I'll talk about the long run, short run, etc. So remember, here always our starting point is a profit function. Okay, so remember this point. Starting from a profit equation, we are doing all these things. Starting with a profit maximizing exercise, we did all these things. We derived the input demand functions, we derived the supply of output, both the things, input demand function, supply function, everything we derived starting from a profit function. So so up to this I could complete. Third point, this long run, short run fact that I'll cover next day. And in between you derive these relations. You practice all these things, check the matters from the book, prepare your own write-up and find out the two derivatives I mentioned. And if you go through the text, I think some confusion sometimes, you become a bit confused, what is happening, etc. So if you go through the text, I hope the confusion which is arising in your mind, that will be also cleared. However, any question, anything? Do anyone have any question? Any clarification you need? Any clarification, any question?